ladies and gentlemen. So today we're looking at 3.4, factoring polynomials. So with our warm-up, it says find the factors. Oops, here we go. It says list the factors of 28. Then it says find the zeros of the quadratic by factoring. And then it says x squared plus 15x plus 36. And we are actually going to skip over this bottom one. So, listing the factors of 28. Factors are numbers that multiply together to give us 28. So, we would have 1 in 28, 2 in 14, and 4 and 7 are all the factors of 28. Finding the zeros of this quadratic of x squared plus 15x plus 36, we have to think about what would that be in factored form. What are numbers that multiply to give us 36? But would also work to add to give us 15 when we distribute out our factored form. And that would be 12 and 3. Solving each of those for x, we would get negative 12 and negative 3. So our objectives for today are to use the factor theorem to determine the factors of a polynomial, and then factor polynomials using special factors and what's called factor by grouping. So the factor theorem. What the factor theorem does is if we're trying to identify a binomial as a factor or not, and we plug it in to the equation, we should get 0. And if we get 0, then we know that it is a factor. So let's put this to practice looking at, example 1. Determine if the binomial x plus 1 is a factor of the polynomial x squared minus 3x plus 1. So what I'm going to do is I'm going to take this x plus 1, and I'm going to set it equal to 0 and solve for x, so I'm going to subtract 1, and I get x equals negative 1. So then what I'm going to do is I'm going to take that value of negative 1 and I'm going to plug it in for x into this equation. So that's going to give me negative 1 squared minus 3 times negative 1 plus 1. I get 1 plus 4 plus 1, and that gives me, here we go. Did I do that right? Oh, that wouldn't be plus 4. Negative 3 times negative 1 is 3. So that gives me 1 plus 3 plus 1, which is 5. Well, that does not equal 0, right? That is not equal to 0. So therefore, x plus 1 is not a factor. What that means for us is that if we were to put this into factored form, x plus 1 would not be part of the factored form of x squared minus 3x plus 1. Looking at example 2, determine if the binomial x plus 2 is a factor of the polynomial 3x to the 4th plus 6x cubed minus 5x minus 10. So, if I'm thinking about this x plus 2 when solving for x, I would get a negative 2. So I'm going to take negative 2 and plug that into this function for x. So I'm going to have 3 times negative 2 to the power of 4 plus 6 times negative 2 to the power of 3 minus 5 times negative 2 minus 10. I end up with a product of 48 here plus a negative 48 or minus 48 plus 10 minus 10. And that gives me 0, which is good, so that means x plus 2 is a factor. All right. So now let's get into some actual factoring and some special methods or special factor patterns that we're going to need to use. The main one is difference of squares. So reminding ourselves that if I have a perfect square minus another perfect square, that's going to factor into a plus b times a minus b. So the first thing we're going to talk about is what's called factor by grouping. Factor by grouping means we're going to be grouping the first two terms together and then the second two terms together to do some factoring here. So starting off, I'm going to group the first two terms together, x x cubed minus x squared. So what is the largest thing that x cubed and x squared have in common? Or what is the greatest common factor between these two terms? And that would be x squared. Well, I had x cubed, but I divided x squared out, which leaves me with x. I had a minus x squared, but I factored out that x squared, so that leaves me with minus 1. And you could always check your work to see if you did this right, because if I go through and take the x squared and multiply it by x, I get x cubed, and x squared times negative 1 is minus x squared, and notice how that matches the original problem that I had factored something out of, so I know I did it right. But the purpose is not to multiply that throughout, the purpose is to factor. That was just checking our work to see that it really does multiply back in to be our original problem. Now what I'm going to do is I'm going to take the second two terms and look at what's the greatest common factor here. I have this minus 25x plus 25. Well, this minus sign is going to carry down, and now my greatest common factor is 25 between these two terms. Keep in mind, I'm factoring out a negative 25 because that's what that middle term was negative, so that is going to carry down. If that middle sign had been plus, I would be adding here. Because I'm factoring out a negative 25, that's going to leave me with this x minus 1. So now what we've done is we've taken something that was 4 terms, we factored the first two and the last 2 terms, so now we have something that is 2 terms. We have the red term and the blue term. Notice between what I have written in red and what I have written in blue, they have something in common. They have an x minus 1 in common, which is a factor, it's the greatest common factor, meaning x minus 1 is something that is being multiplied in the red term and the blue term. So if I factor out or pull out that x minus 1, what I'm left with, which was once x squared times x minus 1, but I've taken the x minus 1 out and now it's being multiplied out front, I'm now left with x squared. I did have minus 25 times x minus 1, but I've pulled the x minus 1 out, so now all I'm left with is minus 25. So it's not that I just moved the x minus 1 altogether, I factored it out, meaning I divided an x minus 1 out. I could go through and take this x minus 1 and multiply it by the x squared and get x squared times x minus 1. And then I could take the x minus 1 and multiply it by the minus 25 and get minus 25 times x minus 1. And you would notice that I get the exact same line as it was written above. But again, the point is not to multiply this all out, the point was to factor it. So I want to leave it like this. Now, I'm not done factoring yet, because I have this x minus 1, which is good to go, but x squared minus 25 could be rewritten as x squared minus 5 squared, because 25 is the same thing as 5 raised to the power of 2. Now we can apply our difference of squares rule that says when you're subtracting 2 perfect squares, it's going to factor into, in this case, x minus 5 and x plus 5. And then our x minus 1 carries down. And we know that we factored this as much as possible because notice how all of our x variables are to the power of 1. All right, let's go through this process again by taking a look at example 4. You might want to try example 4 on your own or watch the video to see an explanation. So we're going to do factor by grouping again. So I'm going to group together the first 2 terms, x cubed and minus 2x squared. The largest factor between these 2 terms is x squared. When I factor that out, that leaves me with x minus 2. Now I'm going to group together my next 2 terms. Notice that that middle sign is minus, so my middle sign here is going to be minus as well. Comparing 9x and 18, greatest common factor is 9. I factor a 9 out from the negative 9x and I get x. I factor a negative 9 out from 18 and I get negative 2. We know we did factor by grouping correctly because notice we have this x minus 2 quantity that is now the same between the purple and the blue term here. X minus 2 is going to become my new greatest common factor, which leaves me with x squared minus 9. X squared minus 9 is a difference of squares because 9 could be written as 3 squared. That means this is going to factor into x minus 3 times x plus 3, and the x minus 2 is going to carry down. All right, that wraps up 3.4.